The blog post discusses a Next.js project that utilizes server actions through a generic custom hook, which is consumed by a generic component. It compares two approaches, GetPostsLen1, which directly fetches posts without the custom hook, and GetPostsLen2, which employs the custom hook and generic component to enhance functionality. The post highlights the advantages of this design, particularly in managing loading states, errors, and successfully displaying data. The author is attempting to implement a simplified version of useActionState to handle generic loading and error states for server actions in Next.js, because the current version of useActionState is not functional in this framework. To install the project packages, you can use the command pnpmi. Alternatively, you can also use npm for the installation. The following lists the usage of this repository. To start the development server, execute the command npm run dev. This command initializes the server for development purposes. The provided code snippet demonstrates the use of a custom hook, useCustomActionState, in a React component using TypeScript. The hook is designed to manage asynchronous actions, specifically fetching the length of posts. The asynchronous function fetchPostsLength is called, and the resulting length is returned. The code also extracts the state, run function, and a pending status indicator from the hook for handling the fetch operation's state management. The provided code snippet is a React, specifically TSX component that includes a button and a state indicator for an asynchronous operation. When the GetPostsLength button is clicked, the function run is triggered. The component features a ServerActionStateDefault component, which displays different states of the action based on whether it's pending, successful, or failed. When the action is successful, it shows an alert with a success message and displays the length of the posts retrieved in a paragraph. The success message is surrounded by a div element, allowing for structured presentation. Overall, this snippet illustrates how to handle asynchronous operations in a React component, showcasing the interaction between user input and state management. The blog post discusses two components, GetPostsLen1 and GetPostsLen2. GetPostsLen1 demonstrates loading behavior without using useCustomActionState, ServerActionStateDefault, or ServerActionStateGen. In contrast, GetPostsLen2 showcases loading functionality while incorporating useCustomActionState along with ServerActionStateDefault and ServerActionStateGen. To see the differences, the reader is instructed to invoke the development server and click on the second button. The text describes a loading indication for a function or feature named GetPostsLen2, suggesting that the system is in the process of retrieving or processing data. An accompanying image illustrates this loading state, emphasizing the visual representation of the operation. The text discusses using a constant named bad post URL in a server action called fetchPostsLength, which causes an error to be displayed for the functionality referred to as GetPostsLen2. An image is provided to illustrate the error. The text instructs the reader to use the constant goodPosts URL within the server action fetchPostsLength to obtain both a success indication and the data related to GetPostsLen2. It is accompanied by an image that likely demonstrates the success of this action. This design has few benefits as listed below. The text discusses a method of executing actions safely and with minimal user interface disruption by using useCustomActionState. It also explains how to visually represent different states of the action, error, loading, success, using ServerActionStateDefault and ServerActionStateGen. The blog post highlights that the ServerActionStateGen feature now allows for data to be null in successful responses, using the data on success can be null option. The text outlines the importance of clearly distinguishing between error handling and successful responses in a system. It emphasizes that errors should be managed separately to address failures effectively, while successful responses should be organized for efficient data management. More information on error handling can be found by following a provided link. The text explains that server actions are triggered with lower priority through transitions, which improves the responsiveness of input fields. The code useCustomActionState hook provides built-in error handling for server actions, enhancing the reliability of user interactions. The text provides an overview of utilizing a TypeScript interface to define an error object, which includes properties like name, message, and an optional stack. It also demonstrates how to throw an exception using this custom error interface with the example, throw new error, something went wrong. The blog post highlights the differences between two hooks, useActionState and useCustomActionState. While useActionState returns an array with 3 elements, useCustomActionState provides a more structured object containing the state, a run function, and a pending status. The object format of useCustomActionState is deemed clearer and less prone to errors. The provided code defines a custom React hook called useCustomActionState that facilitates managing the state of asynchronous actions. The hook takes 2 parameters, an action, which is a function returning a promise, and an initial state, representing the initial state of the data. Internally, it utilizes React's useState to manage the state and useTransition for optimizing state updates during asynchronous operations. The run function, when invoked, triggers the action in a transition, updating the state with either the retrieved data or an error if the promise rejects. Finally, the hook returns the current state, the run function, and a Boolean indicating whether the action is pending, enabling seamless integration of async actions in React components. The provided TypeScript code defines a generic React functional component, ServerActionStateGen, that handles different server action states, loading, success, and error. It takes properties such as isPending, state, and various component types for loading, success, and error states. If isPending is true, it renders the loading component. If there is an error in the state, it displays the error component. If data is not available and the success condition allows for null data, it renders nothing. If everything is in order, it shows the success component. The component is designed to provide user feedback based on the current state of a server action, improving the overall user experience. The provided code snippet defines a React functional component named ServerActionStateDefault, which is designed to manage and display different states of a server action, loading, error, and success, using Material UI components. Here's a summary of its functionality. 1. Props. The component takes 3 props, isPending, state, and success component. isPending, a Boolean indicating if the action is currently pending. State, an object containing the error information. Success component, a component to be rendered upon a successful action. 2. Loading and error handling. The component defines local variables for loading and error components. Loading component renders a default loading component while the action is pending. Error component displays a default error component if there's an error, using details from the state.error object. 3. Rendering logic. The return statement constructs and returns a ServerActionStateGen component, which combines the success, error, and loading components, along with other props indicating the current state of the action. Overall, this component serves as a centralized way to handle and display server action states in a clean and efficient manner. In handling server action errors, there are 2 main scenarios. 1. If the server action throws an error, the system handles it automatically. 2. If the action fails and returns an error within the data, you have 2 options. Handle the error as part of the data in the UI, meaning the data may have mixed quality. Wrap the server action in a structure that throws exceptions for errors, ensuring the data remains strictly valid. This approach allows for flexibility in error management while maintaining data integrity. The blog post discusses a proposed solution focused on server actions, but emphasizes that it can also be applied to various actions, including client-side data fetching. This blog post features a video tutorial titled Boost React UI Responsiveness with useTransition, which demonstrates how to effectively use the useTransition hook in just 4 minutes. The video aims to enhance the responsiveness of React user interfaces. Additionally, there is a section that includes a script for syntax highlighting, likely intended for code snippets within the post.